Hello everyone, my name is Fabian Glöggler. I'm from the University of Applied Sciences in Ulm. As Antonio mentioned, it was a very spontaneous meeting here in Paphos because I wanted to visit a conference, the Intelligent User Interface Conference in Paphos, which was scheduled on Monday to today, to Thursday, but it was postponed to July, of course, because of the situation next to us, and that's because I also came to Cyprus because the books were already the flights were already booked, and I also had vacation at the end. And so this is a perfect opportunity to share my stuff here. Yeah, this talk is about inclusive AI systems for mobile everyday support. And this is a project, a government-funded project, which in the MIC project, which is a German acronym, and it means more inclusion through smart AI for people with disabilities. Some information for me. I'm starting my PhD in April, so I worked on this stuff, but my current position is the research associate in the MIC project, where we develop edge AI systems, which I will show you later. My education, I did my master engineering at the university in Nuremberg. It was about mechatronic and electronic systems. Did my bachelor of engineering also at the University of Applied Sciences in Ulm in medical technology. And before this, I did an apprenticeship as electronics. Here, I just want to share some information about my university, where we located at. You can see here Germany, and here in the south between Munich and Stuttgart is the city called Ulm. It's a very nice city, about 250,000 people. Yeah, and here are some stuffs about our university. We have about 3,000 students, and we are very focused in the practical stuff. So we have internships and cooperation with companies. Yeah, like this. But now back to the theme. I have the project structured in these 4 topics. First, I want to start with the motivation and introduction. After this, we will look at the decentralized AI processing on mobile devices. After this, I want to show you some applications of our MIC project, especially 3 specific applications. And after this, I will give you a short conclusion. First, the motivation and introduction. People with disabilities have, we focus on people with visual impairments, like blind people or age-related vision loss, and also with motor impairments. For example, after a stroke or after a heart attack, people just can keep their hands like this. This is called the thumb in hand position. And these people are excluded in the daily life, especially in their first working space. And in our project, we work together with a healthcare organization. It's called Lebenshilfe. And there we started a workshop and identified a specific task where we can help these people. And one task is especially reading the best before dates on products, because people who can't read don't see if a product is good or not good. And this is just a simple task, but these people cannot do it. And especially in supermarkets, these jobs can be done by people with disabilities, but because they can't read, they are excluded and cannot work there. And AI also often fails for people with disabilities. One big reason is AI need data, which everyone knows, and these people aren't in the data because most of the people don't have disabilities, and people with disabilities aren't in the data, and that's because they are invisible. Another or a specific example is the speech recognition. For example, people with ALS aren't able to use normal speech recognition systems because the systems aren't trained with their speech. Another reason why people with disabilities often fail is because accessibility isn't used in the first step. It's always an afterthought in the development. When people or when companies have money, they say, "Oh, let's do let's do the system accessible," but it's not the first way which they think. And the state of the art shows exactly what I mentioned. Existing AI systems are focused on continuous text recognition, and they cannot reach the best before date. There are two specific systems which we found. One of them is Seeing AI from Microsoft, and the other is OrCam from HelpTech. And this is a demo video from Seeing AI, which we tried to see the best before date, which you can see here.
6. For chat, EULA, words, DEEG, by 306, EG, by 306. 20, DEOCO, EOCO 006, ULIN, for chat, Foromstu, Bester Verbala, VC Medins Hate Barbis, SLE, www.ru.de/v. Sols, Notchsor, Ab, Gisher Language+, +8.
Yeah, everyone sees this isn't working. It's not good for these people. And this app, Seeing AI, is especially developed for people with disabilities. But no Microsoft bashing, but this isn't the way to do it. And so we thought what we can do better. And one other opportunity is to use generative AI, like everyone knows, ChatGPT or Gemini. And this system can also analyze images, but they are also not optimized for the best before date recognition, and they often fail. They are not designed for the small irregular text like it's on the products, the best before date. Generative AI also has a high latency due to the cloud-based processing. And one big problem is the privacy concerns, because we work with sensible data with people with disabilities, and the data privacy must be given. So let's say the state-of-the-art current systems fail to meet requirements for reliability, accessibility, and the independence in everyday use. And this, the objective of this talk is to explore how inclusive AI can support everyday activities. And I want to show you different edge AI systems. Edge AI systems are systems on mobile devices. Like you can see here, a smart glasses. It's a glass with cameras and also augmented reality, or just smartphones. And I also show an hybrid approach where we also use a private hosted cloud where we can run complex systems. Our approach is to develop inclusive AI for the everyday support and with an active user involvement, which I mentioned. We have we work together with a healthcare organization where people with disabilities are, and we also did a workshop where we get their opinion, what they need and what is helpful and what not. With this, I want to continue how to run AI directly on mobile devices, or edge devices. There are two ways. First is generative AI versus edge AI. And generative AI, everyone knows it's a real hype thing. It's ChatGPT, Gemini, DeepSeek. They are dominantly running in the cloud, and they are highly productive, have adaptive content generation, but they need high computing power, high storage resources, every stable network connection. They are not working offline, and the data protection is very critical. Edge AI works the other way around. The processing works directly on the devices itself, and this enables offline use, low latency, and better data protection. But it also means that we have limited resources. To understand the challenge more clearly, let's take a quick look at different model sizes. First, there's GPT-4o from OpenAI, which has approximately 200 billion parameters. And this just works in the cloud structure, which you can see here. This exact model doesn't work on edge AI system. This is not possible. When there's just a model like BERT, which has approximately 340 million parameters, this is possible. And this raises the question, how can we run big models on edge devices? And to do this, let's make it a little bit interactive. One opportunity is to use quantization. And here is an image from a famous person, which gets more and more step even clearer. And when everyone notices this person, it just can call it out who it is. So let's look at it. I think no one recognizes anyone.
Einstein.
Oh, yeah, that's correct. Yeah, it's Albert Einstein, correctly.
Coming from Ulm.
Yeah, and as researchers from Ulm, as he mentioned, yeah, we are very proud that he lived in Ulm for a whole 15 months. But we are celebrating this as he spent his whole life with us. Yeah, this is a quantization, and here in this table you can see on the left side an 8-bit grayscale image with 290,000 pixels. And the memory is about 290 kilobyte. And with the 4-bit quantized image, you just have a memory. You also can reduce the memory with 50%. And even with 3,500 pixel, where people can recognize images like you see it yourself, you save about 99% of the memory. And this is very similar to neural networks. You can quantize the weight matrix. And there are also other opportunities like pruning, knowledge distillation, or low-rank factorization to optimize these models. And this is a way that you can run big models on edge devices. You also have to think that the performance is going a little bit down, but they also perform pretty well. This also shows the key efficient aspects of neural networks. For small, we every time had a trade-off between storage on the top, latency on the left bottom, and energy. And we always have to decide which part we want to focus. And in our part, we want to focus on latency because on edge devices, it's always a user device. And when there's just a latency about 2 or 5 seconds, the user will not use this device in this application. So let's switch to our applications which we developed in our project. First, I want to show the recognition of the best before date on product packaging, which I mentioned before. The idea is pretty easy. First, you have to take a picture of a product, then the image is processed, and the application says the product is expired or the product is good. And all of these components are working on the edge device itself. There's a smartphone and a smart glasses because we focus on both devices, and it's running on both. To look a little bit deeper in the project, we developed this as an Android application. These classes is called View 6 Shield, and it has a standalone running Android device. So you can develop with an SDK apps like you do it in the smartphone. It's pretty easy. We developed this with a state machine, so the system is always in a definite state, and the user can see now the system is in this device. If it's sometimes more latent or a little bit lower, so the user knows that the system is working. The first AI model is a predict rotation classification model for correcting the image, because people who can't read don't know if the text is on the wrong side or so. And with this, we found out that the systems just work very good when the text is in the right orientation. So we developed this orientation system, and it's working with an YOLO architecture, which means you only look once. And it's a fine-tuned model with about 2.5 million parameters, and it predicts the rotation of these images in 30-degree steps. After the image rotation, which is visualized on the right side, the corrected image is input in a find date object recognition model. It's also with an YOLO architecture. This model has 9.5 million parameters, and it predicts the bounding box where the date is located. And after the localization of the date, the text is read by an optical character recognition system. There we use Google MLKit or EasyOCR. And to show you, I have here a small video where I use the smart glasses to analyze a product. I start the searching by an audio output because the handling on these devices is pretty difficult, and users with disabilities should have an easy handling, and so we implemented speech to control the app. So the system now searches, and it found here on the bottom this date, the 1st November 2025. Yeah, and you can see it's the right date. And yeah.
What about the dates that don't have like something to show? Is that date like a dot or a slash or anything? They just numbers together?
Yeah, it's very difficult. Right now I'm setting up a big data set, and there's representing many kinds of different types of dates. Like there's always often the year, then the month, then the day. sometimes first the day, then month, and we need to our system needs to work with each representation of the date. So we represent this in our data set. This
would you be training directly the algorithm from image to the parse date, or you would be just computer vision seeing the numbers and then a simpler model or just an algorithm hard-coded that will normalize it to the date you want to use?
I didn't get the start of your question.
So basically, there are two ways of doing this kind of algorithm. You can use one algorithm that basically black boxing everything end to end from image to the date in a way that is comprehensible for us. Or you can split it by two. First, have the image recognition just taking the numbers. You don't care if it is a day or something. You just take the numbers that look like something you're looking for. And then the next, it may be just hard-coded algorithm because it's pretty simple. There is very finite number of ways how you can write down the date. That basically normalizes it.
Right now, it's a system with more algorithms. Like you can see first the rotation correction and then the find date and then the OCR. But
yeah, I mean from the already the bounding box. So when you have the image in the bounding box up to having the final result.
There's just an OCR and then a logical algorithm which says which identifies the date.
Okay.
Yeah, but we also develop, as I mentioned, I'm setting up a big data set. We also want to develop an end-to-end solution, not with these standalone algorithms. And for these, we use the hybrid approach, where we set up a private GPU, but the solution is now not ready. But we will see later in another application where I show these. Yeah. This is also now with the smartphone. And it also says the 1st November 2025. So let's now switch to the next application, the ROI HR app recognition, the region of interest hand recognition. This idea came when you're in the supermarket, there's not just one product, and the user, when you take a photo, the system don't know which product it has to analyze. And so we developed this system to refine the region which has to be analyzed. And the idea is pretty simple. There's a model which detects the different hand knuckles of a hand. And here is set the index finger with index 8. And then the user can point to a product which he wants to analyze. And then around the index finger is a rectangle, and then just these rectangles analyzed. So you can see when there are multiple products, you can refine the analyze station region. And this is also just working on the edge device, on the smartphone and smart glasses. And this application is just to refine the region. And then afterwards, it can be any downstream system, maybe to analyze the best before date or many other applications. And this is how the system works. It's also working on with an Android application. And there's a real-time on-device AI-powered hand detection. And it works with Google Media's piped hand landmarker model. And this has very low latency and high privacy because it works on the device itself. And as you can see on the right, the hand is detected, and you can refine any hand knuckle if you want. And this is also good for motor impairments, like I mentioned in the beginning, when you had a stroke and people just can keep this hand, they can use their index finger to point to a product. And with this application, you can configure any hand position. And so you can select these hand knuckles to show to an area which it has to be analyzed. And this is the front end on the left side of the smart glasses. And on the right-hand side, it's the front end of the smartphone app. And you, as I said, you can configure in this screen any hand knuckle configuration. And now I want to show you a live demonstration. Or this is also a practical image, but that's not too important. So, sorry, I need a glass.
Now would have been the perfect use case for your
Yeah, exactly. So, you can see now the screen which I see, and when you, when I just start this, you can see the live screen of this application and of the camera, and this application just show the hand recognition. And you can see it's in real time hand recognition with an AI model which runs on the device itself. But the next steps I want to show with the smartphone, because the handling is just more easy. So you right now can see the live screen again. And when I start the Roy HR app, again you can see the live screen of this room and see the hand recognition again. On the smartphone, it's it's just more performant as the glasses, so it's a little bit faster. And here you can see it's also the index finger selected, but when you can change it in the hand and Roy configuration. And as I mentioned, with the hand and thumb configuration, you just can select these hand knuckles, and it's calculated the midpoint of these coordinates. You just can configure the region size. And when I go back, now you can see these hand knuckles are, and so users can define their region of interest with their hand position. And then the goal is to analyze this region of interest in the blue bounding box. And there can be any system like the find date system, or later, or the application after this, which I show. And there's also the goal to combine these applications. And this next application is the ECKI app. It's revised text in plain language. ECKI is a German acronym. But the workflow is also easy. You take a picture of a text, and the text is analyzed or extracted with an OCR, and then is revised into plain language. Plain language is something which you can say is easy language when there is complex text which is pretty difficult to understand, like law text or like documents of the government or something like this. People have problems with these texts, and so this application helps them to understand text with easy vocabulary or just easy words. And this is the approach which I meant. You can take the picture on the edge device, but the processing is working on a back end, which is running in our GPU server at the University of Applied Sciences. So there's also data privacy secured, and we can run complex systems. And this ECKI means plain language for inclusion with AI. And what plain language is, I always said. And this app also works with iOS because we developed it with Flutter. And it's easy, you capture an image, and then the text is extracted with an OCR, which means optical character recognition. It's also running in the backend because, it's like an OCR. Then the text is revised by an LLM with the Mistral model, and the backend is running on the dedicated private GPU server, and there we use free NVIDIA GeForce 4090 to handling these OCR and LLM models. And this is an example. Here's a text from a safety instruction, which is pretty complex. And with the text in plain language, you see it's much shorter. There are not, it's just text in plain language. And to see these, I have brought an example from the university website here of the Neapolis. And I will also show these with the app here. This is the ECKI app. It's developed in German because our group are German-spoken people. And so I tested, it's working with English text, also with Greek text, but the answer of the LLM is in German. So you need to trust me that it's plain language. But here now see the live screen. And when I take a picture of this text, it's uploaded to the backend, and the answer is right now here in German, and you can also output the text via text-to-speech. Exactly. And another example is the Greek text. No, you can help me. I don't understand anything, but I think it's the same text. And when you analyze it, it's again in German plain language. And as I mentioned, with the Roy HR app, where you can analyze different stuff, I also added this exactly application to revise plain text. So you can set here the ROE processing, right now there's a local OCR, but you also can select the plain language. Exactly. And here's another text of a law, which is about the EU AI Act. And when you can just refine this one, then analyze it. It's also processed and uploaded to the backend. And their answer right now is here. And you can see the original image, then the ROE image, and the overlay image. And here's the result of the text in plain language.
This one, you have your own models to do the image to text? Because, you know, for example, right now also, if you put image in Gemini, for example, it can write you what is written in the image.
Yeah, we use a Ministral app, which is the original app, but in the back end, you have to handle an individualized prompt where you describe what you want as an answer of this project. So in this prompt says, we want this text, which comes from the OCR, and we want this text as plain language. And there we define each sentence must be on the next line. Don't use complex vocabulary. We have to describe what we want to this model.
So you add kind of a system prompt.
Yeah, exactly. Yeah. So that's the main part of the presentation. Let's finish it with the conclusion. First, we started with the motivation. What is the problem? Why is it necessary to help people with disabilities? And how can we develop systems to include these people to support them in everyday activities? Then we looked at decentralized AI processing, how this is possible. We have to make these big models smaller with quantization or other actions like pruning, or we have to use a private GPU to process bigger models. And then we looked at these three different applications we developed in our Mike project. The first one is to recognize the back before date. After we have the HOI ROE app, the region of interest hand recognition, and the Asiki app to revise plain text to revise text in plain language. So thank you very much for your attention, and if there are any questions, you feel free to ask them. Yes.